Welcome back to yet another video of Edjo Learning Platform. Today we will discuss mass spectroscopy for many science-oriented objective exams. Mass spectroscopy is an analytical technique that measures the mass to charge ratio of ions. The results are typically present as a mass spectrum, a plot of intensity as a function of the mass to charge ratio. Mass spectroscopy is used in many different fields and in applied to poor sample as well as complex mixtures. Mass spectrum is a plot of the ion signal as a function of mass to charge ratio. That point is very important as far as exam point of view. Mass spectrum is a plot of the ion signal as a function of mass to charge ratio. These spectra are used to determine the elemental or isotopic signature of a sample, the masses of particles of molecule, and to elucidate the chemical identity or structure of molecule and chemical compounds. In typical mass spectroscopy procedure, a sample, which may be solid, liquid, or gaseous, is ionized, for example, by bombarding it with electrons. This may cause some of the sample's molecule to break into charged fragments or simply become charged without fragmenting. These ions are then separated according to their mass to charge ratio, for example by accelerating them and subjecting them to an electric or magnetic field. Ions of the same mass to charge ratio will undergo the same amount of deflection. Ions are detected by a mechanism capable of detecting charged particles, such as an electron multiplier. Results are displayed as a spectrum of signal intensity of detected ions as a function of mass to charge ratio. Atom or molecule in the sample can be identified by correlating non-masses, example an entire molecule, to the identified masses or through a characteristic fragmentation pattern. Mass spectroscopy is another alternative developed recently for rapid analysis of identity based on protein composition. The main demonstration of its capability is again based on the analysis of gliadin protein from wheat grain. This is an instrumental setup in mass spectroscopy. Here sample is available, and here we have ionization chamber, ionization ion accelerating chamber, and finally the ions will come to detector and it can record how was mass spectroscopy work. Mass spectroscopy is a powerful analytical technique used to quantify known material to identify unknown compounds within a sample. To elucidate the structure and the chemical properties of different molecules, the complete process involves the that is conversion of sample into gaseous ion with or without fragmentation, which are then characteristic by their mass to charge ratio and relative abundance. This technique basically studies the effect of ionizing energy on molecule. It depends upon chemical reaction in the gas phase in which sample molecule are consumed during the formation of ionic and neutral species. Process. What all process included in the mass spectroscopy? There are four key stages in the process of mass spectroscopy. First one is ionization, Second one is acceleration, deflection, detention. Ionization, acceleration, deflection, detention. Ionization sources, which all sources included in the ionization and electron ionization, EI. Chemical ionization, we can denote as CI. Field ionization, field desorption, plasma desorption, secondary ion mass spectroscopy. Ionization have either it can be take place in solid phase, liquid phase, or gaseous phase. Ionization sources can be electron ionization, chemical ionization, field ionization, field desorption, plasma desorption, secondary ion mass spectrometry, fast atom bombardment, electrospray ionization, atomic pressure chemical ionization, matrix assisted desorption ionization, MALD. Matrix assisted desorption ionization. And what all analyzers can be used? Magnetic sector mass analyzer, time of flight, quadrupole ion trap, double focusing mass analyzer. Principle of mass spectroscopy based on Newton's second law of motion and momentum. A mass spectroscopy uses this property of matter to plot ions by varying masses on a mass spectrum. From the law, we infer how much mass is related to the inertia and acceleration of the body. This principle is applied to the aspect where ions with different mass to charge ratio are deflected by different angles in an electric or magnetic field. Application of mass spectroscopy. Mass spectroscopy is widely employed in phytochemical analysis due to its capability to identify, measure metabolite having very low molecular weight at very low concentration ranges between nanogram per milliliter. Therefore, it is considered as a trace analysis methodology. A variety of analyte separation techniques like capillary electrophoresis, gas chromatography, high performance liquid chromatography are united with mass spectroscopy for simultaneous separation and determination of analytes called CEMS, GCMS, and HPLC-MS respectively. Mass spectrometers like quadrupole or quadrupole time of flight are frequently employed in companion along with gas chromatography system. Several phytoconstituents are volatile and thermomobile. They can be analyzed by electrospray ionization, matrix assisted laser desorption ionization, MALD. ESI is commonly employed in HPLC, MS, and CEMS. Electrospray ionization and matrix assisted laser desorption ionization is also used in this process. Foreign transform ion cyclotron resonance, Fourier transform ion cyclotron resonance, Orbitrap, time of flight are emerged as a high performance mass analyzers that are able to screen metabolites with fraction of seconds due to their high resolution. Combination of TOF with one quadrupole time of flight or two quadrupole is emerged as a hybrid mass spectrometers. They are able to cover unlimited mass range with high scan rate and high resolving power. Analytes having high molecular weight and temperature sensitive can be effectively analyzed by HPLC coupled with atmospheric pressure ionization mass spectrometer. Some of the recent research articles debated the application of mass spectrometry for the photochemical analysis. Detectors used in mass spectroscopy. Several types of detectors are available for mass spectrometers. The detector used for most routine experiment is the electron multiplier. Another type of detector is photographic plates coated with a silver bromide emulsion. It is sensitive to energetic ions. And another type of mass detectors is Faraday cup, good for checking ion transmission and low sensitivity measurement. High energy diodes with multiplier array, that is, it is fast and sensitive charge detection. Keep watching EduLearning platform for more exam oriented videos. Don't forget to subscribe. Thank you for watching.